This is the part 4 of the video series on properties of perfect squares or square numbers. The video links to the tutorials on part 1, part 2 and part 3 can be found in the description box below. Now we have two tables here having two columns. The first column is of numbers and the second column is their perfect squares. So the perfect square of 1 is 1, of 5 is 25, of 10 is 100. Same thing here. Of 11 you have the perfect square as 121, of 15 is 225 and of 20 is 400. Now if we look at these two numbers, that is 3 and this 7. Now if you look at their perfect squares, since this is a single digit number, therefore it has only one place, that is the units place, and it has 9 at the units place. The perfect square of 7 is 49 and at the units place you have 9. Again look at this 13 and then look at 17. At the units place you have 9 and at the units place, even in this case, you have 9, right? So if you look at this table, no other numbers perfect squares have 9 at their units places. Like this has 1, this has 4, this has 6, this is 5, this is 6, this is 4, this is 1 and this is 0, except these two numbers. Same thing here. No other numbers perfect squares have 9 at their units places. 1, 4, 6, 5, 6, 4, 1 and 0, except these two numbers. And what is unique in these two numbers? This number is ending with 3. It's a single digit number, but it has 3 at the units place, and this number has 7 at the units place. This number has 3 at the units place, and this number has 7 at the units place. If we want to look one more table, that is here. So this is 23 ending with 3. At the units place you have 9. This is 27 ending with 7 and it has at the units place it has 9. No other numbers perfect squares end with 9 except these two numbers. And what's the unique in these two numbers? Either like all these numbers again ending with either 3 or 7, right? So if your perfect square or the given perfect square ends with 9, then the number whose perfect square that number is will either end with 3 or with 7, like 9, 49, 169, 289, 529, 729, right? All end with 9. So in this case the perfect square is 23 ending with 3, ending with 7, ending with 7, ending with 3, ending with 3, ending with 7. So if someone asks you that, can you tell the next 6 perfect squares ending with 9, then your answer will be yes. Like this is 23 and 27, like 3, 7, 13, 17, 23, 27. So you can tell, like in this case you have 33 times 33, whatever you get will end with 9, and then 37 times 37, whatever number you get will end with 9, and since you have to tell 6 perfect squares, next 6 perfect squares, so the next one will be 43 times 43 and your number will end with 9, then 47 times 47 and your number will end with 9, then another 2 will be, the other 2's are 53 times 53 ends with 9. The next one is 57 times 57, that will end with 9, right? So this is like you can quickly tell whether what are the next perfect squares, right? So next one will be 63 times 63 and then 67 times 67. Okay. Another importance of this property, suppose in a question like objective type question, the question is like you have some perfect square and it's given that this perfect square ends with 9. This is the perfect square that's given to us. We don't know, like let's suppose, for example, perfect square. This is a perfect square And the four options are like a number ending with 5, a number ending with 6, a number ending with 7, and the D option is a number ending with 3. So if it is asked of these four options, whose perfect square this number is, so instantly reject these two options because the perfect square ends with 9. So there is no scope for the numbers ending with 5 or 6, or the only options that you should consider is either that should end with 7 or should end with 3. Now whatever number it is, on the basis of that you can find your answer, but you have now in this case you have to focus on only two options. You have already rejected these two options that are useless for you, so that will save your time.